Tangent. A tangent to a circle is a line that intersects the circle at only one point. Tangent to the circle. If the point lies on the circle, then there is only one tangent to the circle at this point, and it is perpendicular to the radius through this point. If the point lies outside the circle, then there are two tangents to the circle from this point. If the point lies inside a circle, there cannot be tangent to the circle for this point. Let's now see about tangent to a circle in detail. Let us now see how to construct a tangent to a circle from a point outside it. Given a circle with center O and P is a point outside the circle, and we have to construct two tangents from point P to the circle. Steps of construction. Step 1. Join PO and bisect it. Let M be the midpoint of PO. Step 2. Taking M as center and MO as radius, draw a circle. Let it intersect the given circle at the points Q and R. Step 3. Join PQ and PR. Then PQ and PR are the required two tangents. Let us now see the justification of the construction through mathematical reasoning. Let us see how the construction works. Join OQ. And angle PQ is an angle in the semicircle. That is, angle PQ equals 90 degrees. Can we say that PQ is perpendicular to OQ? Since OQ is the radius of the given circle, PQ has to be a tangent to the circle. Similarly, PI is also a tangent to the circle. Since PQ is a tangent to the circle and OQ is a radius, then PQ is perpendicular to OQ. Let us see an example. Draw a circle of radius 6 cm. From a point 10 cm away from its center, construct a pair of tangents to the circle and measure their lengths. Let us see the solution now. Steps of construction. Step 1. Taking any point O of the given plane as center, draw a circle of 6 cm radius. Locate a point P 10 cm away from O. Join OP. Step 2. Bisect OP. Let M be the midpoint of PO. Step 3. Taking M as center and MO as radius, draw a circle. Step 4. Let this circle intersect the previous circle at point Q and R. Step 5. Join PQ and PR. PQ and PR are the required tangents. Step 6. The lengths of tangents PQ and PR are 8 cm each. Let us now see the justification of the construction through mathematical reasoning. The construction can be justified by proving that PQ and PR are the tangents to the circle, whose center is O and radius is 6 cm. For this, join OQ and OR. Angle PQ is an angle in the semicircle. We know that angle in a semicircle is a right angle. Therefore, angle PQ equals 90 degrees. We can also say that PQ is perpendicular to OQ, such that OQ is the radius of the circle, PQ as the tangent to circle. Similarly, PR is also a tangent. This justifies the construction. Let us see another example. Draw a circle of radius 3 cm. Take 2 points P and Q on one of its extended diameter, each at a distance of 7 cm from its center. Draw tangents to the circle from these 2 points P and Q. Give the justification of the construction. Let us see the solution. Step 1. Taking any point O on the given plane as center, draw a circle of 3 cm radius. Step 2. Take one of its diameters, PQ, and extend it on both sides. Locate 2 points on this diameter, such that OR equals OS equals 7 cm. Step 3. Bisect OR and OS. Let T and U be the midpoints of OR and OS. Step 4. Taking T and U as its center, and with TO and UO as radius, draw 2 circles. These 2 circles will intersect the circle at point P, W, X, Y respectively. Join RV, RW, SX, and SY. These are the required tangents. Let us see the justification of the construction through mathematical reasoning. The construction can be justified by proving that RV, RW, SY, and Sx are the tangents to the circle, whose center is O and radius is 3 centimeters. For this, join OV, OW, OX, and OY. Angle VO is an angle in the semicircle, as we know that angle in a semicircle is a right angle. Therefore, we have angle VO equals 90 degrees. We can also say that OV is perpendicular to RV. Since OV is the radius of the circle, RV has to be a tangent of the circle. Similarly, OW is the radius of the circle, and angle RWO is an angle in the semicircle. Therefore, OW is perpendicular to RW, thus RW has to be a tangent to the circle. OX is the radius of the circle and angle SXO is an angle in the semicircle. Therefore, OX is perpendicular to SX, thus SX has to be a tangent to the circle. OY is the radius of the circle, and angle SYO is an angle in the semicircle. Therefore, OY is perpendicular to SY, thus SY has to be a tangent to the circle. Thus RV, RW, SY, and SX are the tangents to the circle. This justifies the construction. Example 3. Draw a pair of tangents to a circle of radius 5 centimeters, which are inclined to each other at an angle of 60 degrees. Let us see the solution. Step 1. Draw a circle of radius 5 centimeters, and with center as O. Step 2. Take a point A on the circumference of the circle, and join OA. Draw a perpendicular to OA, at point A. Step 3. Draw a radius OB, making an angle of 120 degree, that is, 180 degree minus 60 degree, with OA. Step 4. Draw a perpendicular to OB at point B, and both the perpendiculars intersect at point P. PA and PB are the required tangents at an angle of 60 degrees. Let us now see the justification of the construction through mathematical reasoning. The construction can be justified by proving that angle at point PB equals 60 degrees. By construction, angle OAP equals 90 degrees, and angle OBP equals 90 degrees. Similarly, by construction we know that angle AOB equals 120 degrees. As we know that the sum of all interior angles of a quadrilateral equals 360 degrees. This implies that angle OAP plus angle AOB plus angle OBP plus angle APB equals 360 degrees. On substituting the values of angle OAP as 90 degrees, angle AOB as 120 degrees, angle OBP as 90 degrees, we get 90 degrees plus 120 degrees plus 90 degrees plus angle APB equals 360 degrees. On simplification, we get angle APB equals 60 degrees. Therefore the justification of the construction